Hello everyone, today I will be talking about question number 6 from the 2009 FRQ. The derivative of a function f is defined by f prime of x equals g of x for -4 is less than or equal to x is less than or equal to 0 and 5e to the negative x over 3 minus 3 for 0 is less than x is less than or equal to 4. The graph of the continuous function f prime shown in the figure above has x-intercepts at x equals -2 and x equals 3 element of 5/3. The graph of g on -4 is less than or equal to x is less than or equal to 0 is a semicircle and f of 0 equals 5. For -4 is less than x is less than 4. Find all values of x at which the graph of f has a point of inflection. Justify your answer. So for this question, we need to know what a point of inflection is. A point P on the curve y equals f of x is a point of inflection if f is continuous there and the concavity changes. There is a point of inflection when f double prime of x changes from negative to positive or vice versa. The derivative of f prime of x equals 0 at the relative min or max of f prime of x. The relative minimums and maximums of f prime of x are at x equals -2 and x equals 0. Therefore, f has a point of inflection at x equals -2 and x equals 0. Justification. At x equals -2, f prime of x changes from decreasing to increasing. At x equals 0, f prime of x changes from increasing to decreasing. So the next question is, find f of -4 and f of 4 given that f of 0 equals 5. So for this question, we need to know the fundamental theorem of calculus, which is, if a function f is continuous on a closed interval from a to b, and capital F is an antiderivative of f on the interval from a to b, then the area equals the definite integral from a to b of f of x dx, which is capital F of b minus capital F of a. So to find f of -4, I'm going to take the definite integral from -4 to 0 of f prime of x dx, which equals definite integral of -4 to 0 of f of 0 minus f of -4. We want to find f of -4, so I'm going to rewrite this as f of 0 minus the definite integral from -4 to 0 of f of 0 minus f of -4. Since we are given that f of 0 equals 5, we can rewrite this again as 5 minus the definite integral from -4 to 0 of f of 0 minus f of -4. To calculate this definite integral, we're going to solve it geometrically. So to do that, we need to calculate the area under this semicircle. So all we have to do is take the area of this rectangle minus the area of this semicircle. So the next step is to find the area of the rectangle and subtract it from the area of the semicircle. So 5 minus 4 times 2, which is the length times the width, minus the area of this semicircle right here, which has a radius 2. So we would get 1/2 pi r squared. So that gives us 5 minus 8 minus 2 pi. So the answer would be 2 pi minus 3. So to find f of 4, we're going to take the integral from 0 to 4 of f prime of x dx, which can be simplified to 5 plus the integral from 0 to 4 of 5 e to negative x over 3 minus 3 dx. So we're going to use the u substitution here, and I'm going to set u equal to negative x over 3, take the derivative, and I get du equals negative 1/3 dx. So negative 3 du equals dx. Plug it back in here, and we get 5 plus the integral from 0 to 4 of negative 15 e to the u minus 3 du. We simplify this integral, we get 5 plus negative 15 e to the u minus 3x. So plugging in negative x over 3 for u, get 5 plus negative 15 e negative x over 3 minus 3x. Okay, now simplifying, we get 5 plus negative 15 e to the negative 4/3 minus 12 minus negative 15. After simplifying this equation, we get the final answer to be 8 minus 15 e to the negative 4 third. For negative 4 is less than or equal to x is less than or equal to 4, find the values of x at which f has an absolute maximum. Justify your answer. Since we're finding an absolute maximum, we're going to use the first derivative test for absolute extreme values. We are given the graph of f prime of x as well as the x-intercept, which is x equals 3 ln of 5 third. Since the graph of f prime of x is greater than 0, for negative 4 is less than or equal to x is less than or equal to 3 ln of 5 third, f of x is increasing on that interval. For 3 ln of 5 third is less than or equal to x is less than or equal to 4, f prime of x is less than 0. Therefore, f of x is decreasing on that interval. X equals 3 ln of 5 third is the absolute maximum on f because it fits the first derivative test for absolute extreme values.